So we just heard about how important technology at the heart of a particular process is. And if we're thinking about the energy transition, the most important technology is going to be solar. And what determines the performance of solar cells and modules? The wafer at the center of it. And the way we've made that has stayed the same for over 30 years. Nexwafe is revolutionizing the solar industry by creating wafers in a different way, additively from the gas phase directly, using epitaxy. So these green solar wafers are exceptionally important because by 2050, 43% of all the energy we use will come from solar. So the value, the total addressable market for this intermediate product by 2030 is already going to be $30 billion and have a double-digit CAGR all the way to 2050. But why is it strategically important? Because in order to achieve these goals, we have to continuously reduce the total cost of electricity, or the levelized cost of electricity. And the way to do that is by increasing the efficiency of these cells and modules. And by engineering the properties of the wafer using epitaxy, we can drive today's efficiency of 22% to 30% by the end of the decade, above the theoretical limits of silicon alone, by being the perfect substrate on which to do tandem. But what is the challenge with this picture? Solar is incredibly important, but this supply chain, especially in wafers, is completely controlled by China today. How are we to achieve the energy transition without having a balanced global supply chain? China already makes 85% of modules, over 90% of cells, but within the wafer area, they essentially have 100% market share. Imagine a geo situation that impedes this particular supply chain from proceeding. That's why there are many initiatives, both in Europe and in the United States, that are looking to reshore. According to McKinsey, already by 2027, there'll be a 100 gigawatt shortfall in the West for wafers alone. And Nexwafe, with our new technology, is able to close that gap because we can be, through innovation, cheaper than China in an unsubsidized scenario. So doing Czochralski, the typical way of making wafers by ingots from a melt, would cost over 64 cents per wafer in the United States before the subsidies of the Inflation Reduction Act, which are very substantive. Those are 53 cents per wafer. So if you're going to do Czochralski, you have to rely on subsidies. But with our technology, we can compete with China directly. Even in the United States, we're cheaper than China's OPEX cost, and in a low-cost country, we're 40% cheaper. So with those 53 cents that I mentioned, we're highly profitable even before we sell our product. And why is this the case? Because traditional Czochralski goes through 7 steps, and by the time you're done, because of the slicing of the ingot, the fact you have to take a cylinder and turn it into a square, only half of the silicon ends up in the final product. In our process, which takes a seed wafer of the right crystallographic orientation and creates a clone on top of it, over 95% of the silicon in the starting materials, which are commodity gases, ends up in the final product. We're twice as silicon efficient as Czochralski, and we're not relying on polysilicon, which is a highly volatile substrate or material, as a starting component. We rely on commodity chemicals instead. So where are we today? Nexwafe is a spin-out from Fraunhofer ISE in Freiburg. In Freiburg, we have built a prototype line including a CVD reactor that is 9 meters long, 20 tons, where we're currently developing the product. We also have a brownfield site an hour south of Berlin in Bitterfeld, where through the funding, the partial funding of our Series D last year by our existing shareholders, we've already built the frame of the EPI facility that will demonstrate first commercial 24/7 production at 250 megawatt scale. We expect to start full operation there after completing the Series D and building out the rest of the facility and starting operations in early 2026. Why is this the perfect location? Because next door we have Evonik and we have Linde that gives the process gases and takes the byproducts of our production, so it creates a closed loop and is the fastest path to market. But from there, it is our strategic partnerships with Reliance, with Aramco, and the support of the IRA that mean that we will be able to scale to 100 gigawatts of production by the end of the decade. Our Series D of 150 million will allow us to complete the facility in Bitterfeld and fully fund the company as we revolutionize the solar industry using new technology. The only way to beat China is to innovate, and that's what Nexwafe represents. Western innovation for a balanced global supply chain. Thank you.